We're going to use the rate of change to write quadratic functions. Also, I'm going to remind you of a few of the other, like domain, range, axis of symmetry, and finding using the vertex to write the equation. So let's go ahead and look at what is the rate of change. The rate of change is what we're going to be looking at to help us identify A in the quadratic formula. We're looking at as it's going to the first step away from the vertex, either to the left or the right. And so let's go ahead and identify a couple of the key features first. And so the vertex is at 0, 0. Some of the other key features that we have are axis of symmetry is x equals 0. It's x equals whatever the x value is here. The domain is from negative infinity to positive infinity. And then your range, you have to look at the graph. Is the graph opening up or down? And in this case, it's opening up. So our vertex is our lowest point, so we look at our y value. Our y value at the lowest point is 0, and our highest point is going to go to the arrows, which are not written on this one, but they would go up here, and so that's the positive infinity. Now let's find the second point when we leave the vertex, either going to the right or left. I typically go right, and so the first point where I go across a crosshair at a true ordered pair is going to be at 1, 3. Excuse me. Yeah, 3. And this is my point 2. This is point 1. And then we're going to plug into the rate of change formula, which is y2 minus y1 over x2 minus x1. And we're going to evaluate the points. And so I'm just going to go ahead and plug them in. And so our y2 was 3, and our y1 was 1. Our x1 was 0, and our y1 was 0. And then we just solve this problem. And so our rate of change is 3 over 1, which is 3. This is the same thing as your A. So let's now write our function. And just going back to what is the original function? This is f of x equals a times x minus h squared plus k. H and k are coming from your vertex. A is coming from your rate of change. So f of x is equal to 3 x minus 0 plus squared plus 0. This combines down to just being x. And so we have 3x squared when you simplify that out. That is our function. Let's look at another one. So, just kind of looking through the pieces, and I'm just going to go ahead and identify. We have our vertex at 1, positive 4. We have our axis of symmetry at x equals 1. Domain is from negative infinity to positive infinity. Range. This time, we're going from our vertex point, that height, down. So that means we always do domain range from lowest to highest. So negative infinity gets listed first, stopping at our highest point, which is 4. And if you haven't noticed it yet, these numbers come from these locations. So now let's find our point 2. And so if I look for my next point, the next good spot I have is at 2 comma 2. And so I'm going to plug into my rate of change formula, which is y2 minus y1 over x2 minus x1. And so our point 2 was 2 for y and 2 for x. And our vertex was at 4 for the y and 1 for the x. And so when I simplify that, I come up with 2 minus 4, which is negative 2, 2 minus 1, 1, which is simplified to negative 2. So this is, again, my A. Now we're going to plug it into that quadratic formula, our quadratic equation, function, which is A times x minus h squared plus k. Remember, this is your x and y values of your vertex. This is your rate of change. And so f of x, A was negative 2. X minus opposite of our x value of vertex, so x minus 1 squared plus 4. This is our formula for this quadratic equation, a quadratic function that's graphed right here. So let's look at this last one. And let's go ahead and identify the vertex, and we're only going to do writing the equation. We're not going to find all the other pieces. So the vertex is at, and if you look at this, we're counting by halves. So halfway between negative 2 and negative 4 is negative 3. So negative 3 comma 4 is the vertex. The next point, I need to go over to the negative 2. I need to figure out what's happening at negative 2. And I am at, remember these are counting by halves, so 4.5. And now we're going to plug into the rate of change formula, which is y2 minus y1 over x2 minus x1. And I typically put my vertex as my second point. If we plug in our point, it was 4.5 minus 4 over, over the x value was negative 2. And then now let's do the y's for the ordered pairs for the vertex, and negative 3 does make a plus. And so we have 0.5 over 1, which is 1/2, or 0.5. The computer is going to want you to put it as fractions, so make sure you can convert back and forth. And so let's go into the formula. F of x equals A times x minus h squared plus k. A is 1/2. X minus our x value of our vertex, which is 3, plus k, which is 4. And my squared. So f of x is equal to that. That is the function that graphed this graph over here.